Today's show is sponsored by Datadog. Now with cloud security posture management, Datadog allows you to see compliance scores across your infrastructure and track conformance to industry benchmarks such as CIS and other regulatory standards, out-of-the-box cloud and infrastructure configuration rules. Datadog Cloud Security Posture Management, CSPM, performs configuration audits across cloud accounts, hosts, and containers. As a special offer for Cloudcast listeners, you can sign up for a free 2-week trial to see for yourself how Datadog can elevate your cloud infrastructure security posture by going to datadog.com/security-cloudcast. That's datadog.com/security-cloudcast. Sign up now and receive a free Datadog t-shirt.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. We're going to jump right into our news. We've got a good bit of news this week. For our first item, Solomon Hykes. If you're not familiar with Solomon is the founder of Docker and before that .cloud and past guest on the show as well. And he has a new company, Dagger.io. Now, not much to the page just yet. There is, of course, a link in the show notes. But Dagger.io is really going to be a modern CI/CD framework. And they mention, I do like this, I kind of found it a little bit humorous, escape YAML hell, right? Because what is one of the big things with CI/CD pipelines? It's a bunch of YAML files and it's a bunch of, scripts kind of cobbled together. And so what they're offering here is avoiding some of that CI lock-in, whether it's GitHub, GitLab, Jenkins, CircleCI, etc., being able to work with all of them. And they are in early access. So if this is of interest to you, go ahead and go to the website and request early access. And speaking of GitLab, let's move on to our second article as well. GitLab did an IPO this week and very successful. And we've been watching GitLab for quite some time, and most folks in the industry like to compare GitLab with GitHub, and really interesting to see where the two ended up. GitHub, of course, was kind of bought, when was it? 2018, maybe 2019, for a little over $7 billion. And I remember at the time everyone kind of talking about that, and that was quite an acquisition. Well, here comes GitLab a number of years later, and the stock announced and hit, and initial valuation was at around $11 billion and closed the day at a little over 103 and pushing the market cap to a little under 15 billion. So huge congrats to GitLab and all the folks out there. A quick side note as well, too, in reading the article, they were known as a remote work company. And in filing of the S1 and on their prospectus, for their address, they just said, address not applicable. I thought that was funny. So they really are continuing to move ahead, and certainly wish them the best of luck. For our next article this week, a lot of us in the industry tend to use Apple's and the MacBook laptops, and Apple made a pretty significant announcement. And I think this was kind of the real release, if you will, of the M1 laptops from last year. They released the next iteration of them, and just fantastic performance, fantastic lower power consumption out of them. Really, really good stats coming out of them. And lots of folks decided they're going to go ahead and pre-order one. Now, why, though? It's not necessarily speeds and feeds on this one. This one is a little bit of return to what made the MacBook and MacBook Pro so great as a laptop from a functionality standpoint from 5 years ago. No touch bar anymore, going back to regular ports. In addition to that, it was interesting to see the evolution of chips and these migrations off of chips and how successful Apple has been doing this for a number of years. This isn't the first time they've done a chip transition. And Steven Sinofsky did a pretty lengthy Twitter thread on it, and it's really worth a good read. It goes all the way back to the early days of instruction sets and chipsets and CISC versus RISC, if anybody still remembers that, and PowerPCs and the transition to Intel, and then the transition from Intel into their own, back into the ARM chipsets. So really fascinating to see kind of under the covers how they're able to achieve something like this and how they got better over the years. And one of the few companies I feel that has done this successfully and has done this successfully multiple times. So with that, definitely go check out that Twitter list or Twitter thread. It is in the show notes. And so with that, we're going to move on to our main topic this week. We're going to be talking with Kevin Hoffman about WebAssembly and wasmCloud right after the break.
Today's show is sponsored by CloudZero. For software-driven companies focused on growing margins, CloudZero is the only cloud cost intelligence platform that puts engineering in control by connecting technical decisions to business results. By analyzing cloud services like AWS and Snowflake, CloudZero provides real-time cost insights that help you maximize margins. Engineering teams can answer critical questions like, who are my most expensive customers? How much does this specific feature cost our business? What's the cost impact of re-architecting this application? With cost anomaly alerts via Slack, product-specific data views, and granular engineering context that makes it easy to investigate any cost, CloudZero is your complete cloud cost intelligence platform, connecting the dots between high-level trends and individual line items. Join companies like Drift, Rapid7, and SeatGeek by visiting cloudzero.com/cloudcast to get started today. That's cloudzero.com/cloudcast. And we're back. And Aaron, there's two things that we love to do probably more than anything on this show. And we don't always get to do a lot of it, but I feel like we haven't done as much this year. But we love to introduce new technologies to folks, and we love to introduce new guests. So why don't you, both introduce our guests, but also let them know what we're going to talk about today.
Yeah, absolutely. So, we've been hearing more and more about WebAssembly and WASM as well. And so we're going to be talking to Kevin Hoffman, CTO at Cosmonic today. And so, Kevin, why don't you do, first of all, welcome to the show, and then do a quick introduction here. Tell everyone a little bit about yourself and your background and what led you to create wasmCloud.
Okay. Well, thanks for having me. My background is almost entirely on the back end. While I've been able to do some front end user interface stuff once in a while, I usually don't admit to it because then people ask me to do it again. But my specialty is in distributed systems, and I've worked for a number of different companies, including Pivotal and Capital One, basically teaching teams and companies to build distributed applications and to build cloud native applications. And mostly what happened was I discovered WebAssembly, and I was looking at it and realized that because of what it is, and I can get into some detail on that in a minute, but because of what it is, if people could build applications where their non-functional requirements were described as contracts, then we could leverage WebAssembly to literally change the way people build distributed applications. And so for the last couple of years, I've been dedicated to building the tooling and hopefully trying to help out creating a community of like-minded people that are all trying to use WebAssembly to build these new, future applications.
Nice. And so, Kevin, let's start there then. Let's begin by talking about WebAssembly. First of all, what is it? Is this a language? Is this a framework? And what problems does it solve for developers?
Okay, so WebAssembly is not a language, nor is it a framework. It's actually a bytecode format. So, um, in a sense, it is a virtual machine. For those that care, it's a stack-based virtual machine. So there are a number of things that WebAssembly virtual machines do faster than uh, register-based virtual machines. So WebAssembly is, as I said, it's a virtual machine format. And one of the things that's interesting about it is that the virtual machine format is portable. So as long as there is a suitable host runtime, a WebAssembly module, a .wasm file, can run anywhere. And so that includes, the edge, the cloud, obviously the browser, since that's where it started, and everywhere in between. And so one of the interesting things about WebAssembly, in addition to it being portable, but it's also portable and small and fast, and it can't do anything without the host runtime. So it has none of the instructions in WebAssembly allow you to access the operating system, read from files, although there's an extension called WASI that lets you do that. But even that is within a sandbox. And the WebAssembly memory is an isolated block of memory that can't cross that boundary between the WebAssembly module and the host runtime. So if you think about some of the portability stuff, imagine that someone were to change the format of, say, video games, so that if you built your game in this particular format, it would run on Xbox, PlayStation, PC, and Nintendo Switch, all without anybody having to change any code. And, business and competition aside, that kind of ubiquity is one of the things that a lot of us are really looking forward to with WebAssembly.
Yeah, let me ask a dumb question, sort of as a follow up, because I'm in my brain, the way I always learn stuff is sort of compare it to the older thing. We've heard this idea of kind of write once portability back in the Java days. Java again, Java VM based and so forth. Like, walk us through why this is different, or what the old thing couldn't do that this now does. Is it just faster technology, smaller footprint, or is there something just really different now about the way the web and the cloud works that maybe those old things weren't the right fit for?
Yeah, that's actually a great question. And I think one of the things that WebAssembly does better, or maybe not better, but more suited towards the kind of distributed apps that I'm talking about, is WebAssembly does less. So, Java is, there is a bytecode format for Java, and, technically there's a virtual machine there. But as I mentioned earlier, there are instructions in the Java virtual machine that talk to the operating system, that talk to the network, that talk to hardware resources, and all of that other stuff. So while on paper, a bytecode virtual machine sounds like it could be either WebAssembly or Java. WebAssembly has a really, really limited set of instructions. And my opinion on that is that that's actually a really good thing. The less that it does contributes to how portable it is. So, regardless of what CPU architecture you're using or what operating system you're running on, as long as the host runtime knows how to interpret that WebAssembly module, it'll work. And those of us who have Java experience in the past know that that's just not the case. There are, there's all sorts of problems that you have trying to get a compiled set of Java to run everywhere.
Yeah, and Kevin, I think that's probably been, almost a bit of a running joke with the Java, right? Like everyone knows what the ideal was, and everyone knows about the right ones to run anywhere kind of philosophy. But also, a lot of people also know that had various levels of success. Let's just put it that way. So then let's talk about how that kind of transfers into wasmCloud. Once somebody has built something leveraging WebAssembly, how does it interact with wasmCloud, and give everyone maybe as part of that an introduction to wasmCloud and what is wasmCloud as well?
Sure. Well, so the progression that we think a lot of people have is you get to WebAssembly and you start with the simplest WebAssembly example, which is write a module that adds 2 numbers, and everything seems fine. But one of the limitations of WebAssembly is that it only speaks numbers. The input and output from functions can only be numbers. WebAssembly doesn't have string parameters. It doesn't have blobs, doesn't have hash maps, none of the things that we take for granted in most of our regular programming environments. So right after people discover low-level WebAssembly, the next thing they want to do is figure out how to send complex payloads between the host runtime and the WebAssembly module. And so that's where the foundation of wasmCloud came in. The first problem we were trying to solve was, how do we let people, serialize arbitrary structures and send them into WebAssembly functions as parameters, and then get robust answers that are more than just, numbers. And then from there, we went to, how do I make it so that these WebAssembly modules can run, following the and inspired by the actor model? How do we make it so that people can write actors as WebAssembly modules, where the developer only has to worry about single-threaded business logic, and the runtime takes care of binding that business logic to non-functional requirements like a database or a web server or all the other stuff we use on a daily basis. And then from there, how do we distribute it so that these actors are scalable across any number of hosts, and our lattice network makes it so that you can deploy all these actors across multiple disparate infrastructures and stitch them all together into a single flat topology. So one of the things that I like to describe as the inspiration for wasmCloud is frustration. So I've spent years and years and years building enterprise applications and writing monoliths and services that all have these tight couplings to databases and web servers and all the other stuff that we need. And watching our business logic get hidden underneath mountains of spaghetti code. And so I just wanted to combine the small size, and power and security and portability of WebAssembly into a distributed actor model. And so that's where wasmCloud came from.
And the company that you're now CTO for, and that you guys recently sort of became public now in the main domain, Cosmonic, that's sort of at the foundation of what you guys are doing. I know the company's still in really early days, and sort of product TBD, but WASM is somewhat at the center of what you guys are planning to build, correct?
Yeah. It's the classic symbiotic relationship. We hope, between a company and an open source technology, where Cosmonic is sponsoring and furthering the development of wasmCloud, and we're hosting and sponsoring the WASM Day conference, which is today at KubeCon, and generally trying to stimulate and grow the WebAssembly community in general, because we're both as product developers and technologists, we are convinced that WebAssembly is the future of distributed computing, and so we're there trying to make the products and tooling and community to move that forward.
So I'm curious because again in my mind I'm trying to kind of do some comparisons of things which may or may not be the best idea. I feel like it was a couple of years ago, Solomon Hykes, who famously created Docker and some other things, sent out a tweet and he said, "Hey, if WASM and WASI had existed back at the time when I created Docker, I never would have created Docker. This would have changed what we did." Can you kind of compare, because a lot of folks that listen to the show kind of understand what containers do and what Docker did and how it sort of separated this user space which had dependencies from the underlying runtime and the operating system. Can you kind of compare that way of doing things versus what WASM does and what wasmCloud does? Just they may not be a one-to-one comparison, but kind of why someone like Solomon might make a statement like that, given the advancement of technology.
Yeah, that's one of my.
That's probably a question that needs a whiteboard, but as best you can.
It's one of my favorite quotes, and the evolution of technology and how we build applications that changes when the deployment format or the unit of deployment changes. So, we build libraries and frameworks and tools, and those make incremental changes. But when we change the actual thing that we deploy, that's when the entire landscape changes. And that changed when we went from building on bare metal to building on virtual machines. And that changed again when we switched from virtual machines to Docker images. So this progression is us continuing to remove, abstract, and virtualize things that we care less and less about. And so that transition from Docker to WebAssembly, we hope is going to be something similar, where when you go from virtual machines to Docker, you're now virtualizing the operating system. And then when you go from Docker to WebAssembly modules, assuming you have the right host runtime, you're now abstracting all of your non-functional requirements and able to encode nothing but pure business logic.
Yeah, so it's all about just keep moving up the stack and keep differentiating and leaving by the wayside all of that stuff that's, cruft, if you will, or things that doesn't necessarily move the needle as much with the business, right?
Yeah. So if you think about historically, the reason to change that motivates developers to go and patch production software or, redeploy things, what's the percentage of time that the change you're making is to change a feature or the business logic versus, patching a security vulnerability or upgrading a library dependency that you own because your app consumes it, changing another non-functional requirement that's tightly coupled to your app. My experience is 90% of the time that I am in there working on code and deploying new things has nothing whatsoever to do with my business logic, and it's all about the non-functional requirements and the other cruft that comes along with it. And so we're hoping that WebAssembly will change that and invert that ratio so that we can go on forward and spend 90% of our time working on features and only 10% or hopefully even less working on non-functional requirements.
Yeah, and Kevin, that makes perfect sense. And I'll move on real quick to kind of the next thing, which is very timely. So as of when we're recording this, yesterday was WASM Day at Cloud Native Con. And so what were some of the highlights and focus areas from the event?
Actually, I believe WASM Day is today. It starts at 11 o'clock Eastern, as far as I know.
I thought it was yesterday. I apologize.
We're good either way because we'll end up publishing this just after
Yeah, that
the
is
con,
true.
so
That is
everybody
true.
will be everybody will be a time traveler at that point. So
Through the magic of recording, time will itself out. Yeah, but the schedule is really amazing because you have people that are using WebAssembly for what you might think WebAssembly would be used for, which is just to write stuff that runs in the browser. But you've also got people that are building functions, very Lambda-like functions that are running out on the edge using things like Cloudflare workers. And those are written in WebAssembly. You've got people building stuff in the cloud to, like wasmCloud, where they're using distributed actor models to build WebAssembly. There's talks about how to integrate WebAssembly with Kubernetes, and so it's being picked up everywhere, and I'm super excited to see what people are going to do with it next.
Yeah, what are some of the kind of, you mentioned there's folks that are doing this, out there in the wild and in anger, if you will. What are some of the kind of early use cases, some of the simple, low-hanging fruit that people get started with?
So in the cloud space, there's a project called Linkerd, and people are able to write, low-level networking filters using WebAssembly. There are, like I mentioned, there's Cloudflare, and there's actually a couple of other companies in this space where they're letting you write WebAssembly functions and deploy them all the way out to the edge so that the code executes as close to the customer as possible. And then you've got where I'm focusing, which is cloud as well as edge. So sort of treating, my goal is to treat the edge, cloud, browser, and IoT device all as a uniform, think of it like an empty vessel for compute. You can throw those modules anywhere and run them anywhere, and optimize your deployment strategy that way.
And Kevin, we are kind of at time here. I'll kind of end with this. If folks are interested out there, and shameless plug for you as well. You have a book coming out, or already out, Programming WebAssembly with Rust. What are some ways folks can get started with both WebAssembly and wasmCloud?
Sure. So, as you mentioned, shameless self-promotion there. I do have a book that goes through, how to do some basic WebAssembly stuff with Rust. There are some languages that are designed specifically to target WebAssembly and nothing else, like AssemblyScript and Grain. Those are, so if you go to AssemblyScript.org, there's a set of good tutorials to get you started on writing AssemblyScript, which is I think that it's technically a subset of JavaScript, but if you're familiar with JavaScript, then using AssemblyScript may be the lowest friction way to get introduced to WebAssembly. If you're more of a systems language type person, then Rust might be a good avenue. C and C++ obviously have really good tooling as well. So it really just depends on sort of the perspective that you want to take when you approach it. You can either write languages that target WebAssembly directly, or you can use your favorite language, and then if it supports it, have it compile into WebAssembly modules. If you're a fan of Go, I know TinyGo has a pretty good story for compiling into WebAssembly. I think I haven't played with it recently, but the last time I explored it, the full Go language had some issues being able to produce WebAssembly stuff that didn't require kind of custom JavaScript shims.
Nice. Well, listen, Kevin, thank you so much for the time this morning. I know sometimes as somebody who's expert in this stuff, it can be a little tedious talking to newbies like ourselves, but it's useful for us to kind of be able to pick your brain even at the most basic level and really kind of, put it into the hierarchy of things that we've seen evolve over time. And so not only, first off, congratulations on the book being published. We've both been through that ourselves. We know that's an unbelievable achievement and sometimes feels like a lonely achievement, but congratulations on that. Congratulations on Cosmotic launching and folks go out and take a look. They're, if you're interested in WebAssembly, if you're interested in WASM, definitely, a company to take a look at, especially if the founders and the creators of the technology are starting the company, you're going to be in good hands in terms of being able to grow with it. So, Kevin, sort of last thing for you. What's the best way if people want to either pick your brain or, kind of learn more about this, learn more about what you guys are doing? What's the best way to engage with you, or what's, how do you typically engage with communities?
So Twitter, probably a pretty good way. I'm usually pretty responsive on Twitter. wasmCloud also has a Slack that we use. You can also use the CNCF Slack. Because wasmCloud is now that's a recent change, but wasmCloud is now a CNCF project. So you can use the wasmCloud channel in the CNCF Slack, and I'm always lurking there as well. Pretty easy to find.
Nice. Well, Aaron, again, thank you to Kevin for the time this morning. Aaron, you want to wrap it up and take us home?
Yes, absolutely. So everyone, thank you so much for listening. And if you enjoy the show, please consider leaving us a review wherever you get your favorite podcast, or please tell a friend as well. And if you have any ideas for future shows or future guests, you know how to reach out to us with all the usual channels. It's all in the show notes as well. And so for Brian and I, thank you very much for listening this week, and we'll talk to everyone next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.